There's a national committee that works on cereal grains, and one of the product that just came on campus was yesterday or so is a new booklet, and you maybe have one from a few years ago, but it's a very nice guide, very visual in terms of diseases. And so Eric Wolf out of Kansas takes the lead on that, and with a number of other people contributing. So I'd just like to emphasize that resource. We'll cover a couple of those diseases, and then some of the things that we're most fearful of, or in terms of risk management, a couple of diseases that we ought to really key in on. So I'll cover just a couple of things here, and then I'll turn it over to Martin too. So on the index, if you open that up, as you know, a lot of the diseases in wheat can be of viral in nature, or bacterial, or fungal. Fungal are by far the most important. And of the fungal diseases, of course, the leaf diseases. Those are the ones that I say we lose 10, 20% of our yield every year to that. You can't say that with soybeans and corn, but I guess I dare to say that with wheat. At least over the decades, that has been the trend. And then one head disease, and that's Fusarium head blight, of course. So I want to key in on a couple of fungal diseases. There's probably 4 that we see every year. And just like with weed control programs of before glyphosate, probably, you could always count, if you're building a broadleaf weed program, you would always say, okay, any field it is, it's going to have some ragweed, it's going to have pigweed, it's going to have lamb's quarter. That's just how it is. Well, with wheat, we always have these 4 diseases, and they will be there. It happens every year. Depending on the weather conditions, one will dominate over another. Well, the first thing is powdery mildew. You guys know this. This is one you're very familiar with. I am struck over the decades how much progress has been made. We have a lot better resistant varieties now with powdery mildew, but it's still very present. So in the first, starting last fall, and in fact in 2 weeks, go out, you'll find powdery mildew and susceptible varieties. It's just going to be there. And as temperatures warm up, it tends to disappear, unless it's given an opening. But even powdery mildew will crawl up all the way to the flag leaf and on the head. I think it was 2008 is the last time I saw that, and it's just incredible. But that's one that's always with us. The other one that's always with us is a Septoria leaf blotch. This also could be found last fall, and it's going to be there if it's not there already. And so you can watch for that, and there's another ones that kind of just slip a few bushels away from you every year. And another leaf spot that's important, and we don't have to necessarily look, as you look at the pictures in your booklet, it's really hard to discern one from the other. But basically, if it's cool out, and it's early in the season and it's cool, it's Septoria leaf spot. But as we get into flowering and later, the leaf spot, and if it's naturally warm out, about average temperature, it's very likely Stagonospora. But in terms of fungicides, they react very similar, and fungicides help us a great deal. And then lastly, as you all know, is leaf rust. It blows in every year. And in fact, if you don't have it during the season, just look at the volunteer wheat that's coming up. You'll very likely still find this disease. So those are the ones that really account for 5, 10, 15, 20, 30% of our yield in there. And then the one that's really scaring us a little bit is stripe rust. You heard probably Marty and I talk about this before, but we're going to have to hit on it again. Partly, as Eric alluded to, we really weren't breeding for this one over the years for the most part. And so we have a lot of good varieties that are actually quite susceptible, and it really made a difference. And that's one thing we learned last year is variety made a huge difference in this particular variety, particular disease. Yeah, go ahead.
And so a couple of things we just want to point out with that stripe rust too, in terms of identifying it, because last year was the first year that we sort of saw this. Very early on, you won't get those characteristic stripes that you do on older plants. Okay, so you can see here a photo that was taken in early May of last year, right? And the pustules are not lined up in stripes just yet. You go back one slide, you can see on these older plants you get those very classic stripes. So just early in the season, right? it'll look a little bit like normal sort of leaf rust. So just something to be aware of. Of course, all these pustules here have thousands of spores in them, and you can see a microscope photo down the bottom left-hand corner there of those spores. And that's part of the problem, right? This thing cycles very quickly. Every 10 days or so, you get spore infecting a plant, bursting out of that epidermis and spreading spores again. And so it moves very quickly and has the potential to really cause epidemics in a very quick fashion. So where did it come from, and why haven't we seen it before? Well, they're good questions. It's partly what we're trying to figure out. So there was some thought that maybe it had overwintered due to the mild winter that we had last year, right? And there's a potential of that. But we believe the main source of inoculum is really from southern states having an earlier spring, a less severe winter, inoculum building rapidly down there and then moving north, right? And we see this with a lot of other rust diseases. All of these rusts, including corn rust, they need that living green host material to survive, okay? So typically during our winters, we're not really going to have survival of this disease this far north. These photos of this mower here are taken from Oklahoma at the start of April of last year. And so they were mowing a wheat hay field, and as you can see, all of that orange spores is rust, but it's not rust, right? It's the pathogen rust, not rust on the equipment, and you can see it on this guy's jeans and boots as well. So, right around April, we had a lot of those spores being produced in Oklahoma, and they just shifted north with weather events, okay? So we believe that that's where our epidemic came from last year. So earlier on, I guess we were probably betting that maybe we weren't going to see that this coming season, and we still don't know how things are going to play out, right? We're going to have to wait and see a little bit. This is just a map I pulled off of one of these websites looking at how early spring is coming, right? And so the colour is just showing you how early spring is coming for those southern regions in the US. And it sounds like a lot of flowers are blooming a lot earlier than normal, and there's certainly rust activity. This picture here is from my colleague down in Mississippi. You're seeing stripe rust down there, and that was in February. And that's reasonably typical for that time of the year down there. But with this early spring, perhaps we are going to get that pathogen, that disease really getting going, and if that happens, we might see a repeat of 2016. So that's just something to be on the lookout for. Thankfully, between us and the southern US, there's a lot of other states. So we'll be keeping a really close eye on this, and if we see it blowing up again, we'll certainly get the word out in terms of what other people are seeing. Last year, we didn't plan to have fungicide trials for stripe rust, obviously, right? Because we weren't expecting it. But we did happen to have fungicide trials out looking at different chemistries and how they affect yield. And this is just an example shot. So on the left-hand side there, you can see an untreated plot, and you can see obviously that's very yellowed from the stripe rust. On the right-hand side, you can see an application at flagleaf, a fungicide application at flag. And that seemed to be, at least in our trials on campus, one of the sort of optimal times in terms of controlling this disease. So we have a number of opportunities to control leaf diseases depending on what we're trying to battle that season. We typically talk about a T1 at the Feeks sort of 6 growth stage, a T2 meaning Feeks 9 or flagleaf, and then a T3, which is typically that very important one, right, for head scab control, right at flowering. So here's some data from some different trials, and this is just yield relative to our untreated checks in different trials. And I just wanted to point out here the effect of timing on the disease control. Okay. So what we saw on campus, it was just a little bit different to what Martin saw in Sanilac here, but that Feeks 9 application timing seemed to be very important for trying to control that stripe rust. Okay, that flagleaf application timing. The other timings that we had, including T1, early, or that late, that T3 application, provided some protection, but not quite as much as that T2 application. And we also tried some sort of rescue applications once disease had already hit, and maybe there was some benefit sometimes, but it was really very variable. Once the damage is done, it's hard, obviously, to bring those plants back. And here's some data from Martin. Do you want to comment on this one? This is from his Sanilac location.
With our standard first application at tillering, followed by the flowering, did very well. I will say that if I am growing a susceptible variety, and we'll touch on those too, or you have that in your packet, I wouldn't use the half rate. I think you were using, in some of yours, a half rate of Priaxor. I think with our focus on the triazoles, but this coming spring on susceptible varieties, just as insurance, if it's your standard program, I'd use pretty full rates. I wouldn't cut that rate back, and then just be timely with your flowering. But yes, it is one, I think, Marty, you would agree, and I think this, your data suggests this too, that okay, I missed it. The neighbors are talking about, your field man says, boy, you're getting some stripe rust in there, you're still okay. But if in fact you haven't used an early spray, then gear up. Because the other thing we learned last year, and Marty showed this on campus, once it gets ahead of you, there's no catching up. But getting a little bit in the vegetative state, that's okay. That's not getting ahead. But once the head comes out and you try to catch up, and we found this in commercial fields too. We've had, boy, I was talking 10, 20 bushel yield loss with fungicides. You get this one on a susceptible variety, and we had 50% loss in some of our fields.
Okay, and just in terms of products that we can use for stripe rust management, we're pretty fortunate. We have a lot of different chemistries that we're able to use, and I think they're on your handouts too, and if not, they're online here as well. So basically, there's a large range to choose from, and they have what we would rate as very good or excellent performance. Okay, so there is a lot of opportunities there in terms of selecting different chemistries. And stripe rust susceptibility, of course, is an incredibly important component of this, and that's something that Eric's already touched on this morning. You guys have a handout here for...
Yeah, if you would look at that in your packet, just because we've never had stripe rust like this before ever in Michigan, I'm going to say, Eric and his team was able to rate the varieties that are in the performance trials, and this is hugely important. You'll notice some very good varieties that are brand new, and they could be terrible in stripe rust, whereas some of our old varieties may be poor or not, but there's a huge different range. The other thing I wanted to point out is that the ratings that they give are relative. So when we say resistant, I would say from our experience last year, yeah, we didn't really benefit from, we didn't really need to protect those. But even in the moderately resistant, some of those varieties lost some bushels. So don't go to sleep on those. Even if your variety is given a medium resistance or moderately resistant rating, we've had varieties this past year that definitely took a hit from stripe rust because it was present and it follows. So what I want to emphasize, just see, even if moderate resistant on a light infection year, that's fine. If we get a repeat of last year, not so fine. So be on the defensive there.
Mm-hmm. All right, and this is just a summary slide, so let me just skip over this. So the other thing we just wanted to mention, of course, is head scab, and we were very fortunate last season, but we're yet to see how this season is going to pan out. So I just wanted to cover a couple of things. And before I do that, this morning my student Michaela Brunig was here at a poster out in that trade show. So she's got a project. What we're trying to do here is look at the pathogens that are causing head scab on wheat and then ear mold on corn as well, right? Because very often it's the same pathogen that's causing disease on both. And the concept here is really to figure out first which species we have, because we need to know which species are out there to make sure that we're controlling them correctly. We can also hand those off to the breeding crew to make sure that they're using the correct pathogens to screen their wheat varieties for resistance rate. Then we're going to take a look at the toxins that those fungi are producing, so we know which fungi are producing which toxins to get a better understanding there. And then their level of fungicide sensitivity. So when it comes down to it, how well are our chemistries working in terms of control? And what are the resistance concerns in terms of those fungal pathogens developing fungicide resistance, which is a constant concern. So if you don't manage to get her information down, by all means, please contact me or let Martin know. This coming season, if unfortunately you get head scab in your field, and would like to participate, we just like to come in, collect a few heads. She'll go in and do some sampling from those to figure out which species you have and the fungicide sensitivity of those species. Okay, so let's just summarize a couple of fungicide trials that have been going on now for a number of years, and Martin's been participating in these for many years. The first round of trials, or version 1, was really to figure out which chemistries were effective, okay? And so there's a number of states participating in this, as you can see from that graphic there. And so we looked at the tebuconazole, or Folicure, which is now generically available, Proline, Prosaro, and Carumba. And the higher the bar, the better here, okay? So what we're looking at here is percentage control on the number of scabbed heads out in the field. Okay, so we're able to reduce the number of scabbed heads in the field by about 40% with that tebuconazole, or about 50% from those other 3 products, okay, the Proline, Prosaro, and Carumba. In terms of DON, the tebuconazole doesn't look quite as good, right? In terms of percentage reduction, we're only hitting about 20 or so percent reduction in DON, but it is a much cheaper product. The Proline, Prosaro, Carumba, we're hitting around about that 40% mark in terms of reduction in DON that we see in that harvested grain. Okay, so that was the first round of trials. The second round of trials, Martin did up in the thumb and we did down on campus as well, okay? And we used Ambassador as our susceptible check. You know, it gets a lot of head scab and leaf diseases too. We use that Dynagro 9242 as our partially resistant check. And then a couple of lines from Eric's program too, this F1014 and E6012. And we had different treatments. And the idea here is really to go in and see what our window of fungicide timing could be. Does it all have to go right on it at the beginning of flowering, as we would have recommended in the past, or is there a window beyond that initial beginning of flowering? So we had non-sprayed and non-inoculated checks, and then we had one where we were inoculating with the pathogen. We're not spraying either. Our standard recommendation, so a fungicide at flowering, or we had treatments 2, 4, or 6 days beyond the beginning of flowering, just to see how big that window is, right? If you can't get into the field at flowering, can you wait 6 days beyond that beginning of flowering and still get good disease control? So that's what this question was aimed at answering. Here's how we do it on campus. And this is part of that MIST system that Eric was talking about. We put the chemistries on with a backpack sprayer. Obviously, we're a small plot. It allows us to look at a lot of different things within a small area. Martin used a tractor-mounted sprayer. In terms of data then, so here's probably one of the more important slides, just to give you a sense of what we found in that trial. So what you're looking at here is the amount of head scab that was found on in those plots, okay? The red bars are showing you the control plots where you put no fungicide on. And there are 2 important messages I want you guys to take away from this, okay? I've grouped the results by variety. So those first 6 bars are the Ambassador. Then we're looking at the 9242 and then those couple of lines from Eric's program, okay? So first of all, you can see between the Ambassador and the 9242 a really big difference, right? The amount of head scab that develops, okay? So in that Ambassador where we're not spraying, we get a large amount of disease developing in those plots compared to the 9242. So that's really demonstrating the effect of resistance. And so if you're dealing with head scab year after year, have a look at the resistance package that you're using to try and manage that disease, right? Because it can be a very large player in terms of managing disease. The second part is the effect of the fungicide. It's very evident on that Ambassador. You can see that either right at flowering, 2, 4, or 6 days beyond flowering, we get pretty good disease reduction, right? It's not 100% control. It hardly ever is with fungal diseases, but we're able to really significantly push that disease down. And it demonstrates that we could go out right at flowering, or we can wait up to about 6 days beyond the beginning of flowering and still get very good head scab control, okay? And you can see the same pattern on that 9242. Obviously the bars are much lower, right? We're starting with far less disease than we were with the Ambassador, but you can see that those fungicides do also assist in reducing the amount of disease that develops. And the DON data supports that as well, and the trials that Martin ran also support this. And this was done in many locations, Ohio, Wisconsin, etc., and the data was all panning out in this direction, so it was really, really helpful information to have. I'm going to say a couple of words about variety resistance here.
Yeah, and a lot of you guys helped with this. Actually, it's the varieties that are most commonly grown in Michigan based on the survey results, but we attached to that, and I guess Eric Dennis and I worked on this survey, and then I think we came to agreement on the designation in terms of expressing susceptibility to scab. And Eric emphasized that, and I want to re-emphasize that because I don't think I could never say this before. There's two ways to reduce your DON levels or fusarium levels in wheat. And one, as we've talked about for a number of years now, is fungicides. But in my book, is for the first time, we're really facing the idea of reducing DON and cutting it in half based on your variety selection. There never has been that much out there to speak of, but in recent years it has. So I want to emphasize with a soft white, we have not made that much progress in the last 5 years. Eric's going to change that here, and other breeders, because there's more emphasis. We are still extremely exposed using Ambassador. I rate that as very susceptible. Canada, I think last year, was it? Yeah. Remember last year at this program, Canada does not permit any susceptibles to be acceptably to be grown in Michigan. We still have a couple of very susceptibles. In soft reds, we're doing much, much better. Now, if you take a look at Red Dragon versus 25R40, Red Dragon will have half the DON level that R40 is. R40, I guess I'll pick on that one because it just really produced it. But boy, you better watch your backside because it is very susceptible, or we call it susceptible to DON. And so that's not a reason to run away, but I'm sure, and you can find this on the wheat website too, it's a survey response to Michigan wheat varieties being grown, and then our assignment in terms of susceptibility in terms of head scab. So #1 disease in Michigan, showing the separation by varieties. Pretty good document to slip in that little resource booklet as you look into next fall, or as you build your fungicide program.
Okay. And just another reminder too, if you're interested in the potential risk for head scab, this website here, hosted through Penn State, is a really good model for the amount of head scab risk. This was taken from last year's, where we were, anyway, it doesn't really matter, but what you can see there, Michigan was showing up in green, so we were very low risk last year. So it's just a handy additional tool to have a look at your potential for head scab risk each season. And that's all I have. So with that, thanks to Michigan Wheat for the support, and we'd be happy to take any questions that you guys have.
Is there any research that's been done, and I don't care what variety of wheat or what disease it has, if you use your wheat over, like we don't plant all certified, we use some and keep it over. If there's a disease or a variety, if there is a disease in one stem out of 10, is that plant going to produce diseased plants again next year or not? Is there any study done on that?
The one I like to scout for when I'm deciding whether or not use Ben Run seed, I walk that field, and one indicator disease I like to use is loose smut. If you look at the book, if I find any loose smut in that field, because that's one disease that is seed-borne, and it also means to me that you have to treat every seed. And those are the ones, if you're going to use it anyway, get a professional to treat that seed. Yeah.
I'm saying, are we still asking for trouble if we have a field that we go in and there's maybe 2 stalks out of 20 that's got any one disease? If you use that for your seed wheat next year,
Loose smut is one, because it infects so broadly. That's one. The other seed-borne, I would say probably you're still okay, assuming that your professionally treating every seed. What say you?
Yeah, I agree. I mean, it's really about the diseases that you're looking at, right? If it's not seed transmissible, it's not a problem. And if
One variety is no different than others, I mean,
no, variety shouldn't really matter. It's about what diseases are showing up, I guess. And I would certainly scout those fields very intensively and make sure you pick the cleanest seed that you can. I mean, and then get it treated, especially if you've got those diseases that are, to be seed transmitted. Yeah.
And one thing with this resource book, and with your experience, and I know we're talking to some fieldmen here and fieldwomen as well, if you can just share the what you're seeing out there in terms of any striped rust or any rare disease, that's really benefits Eric's program and all of us, because we really don't have a very detailed survey of all the diseases that do infect in Michigan. And striped rust is a good example. When we get a disease like that can walk away with half our yield, we'd like to know about it sooner than later, just as you would. So share the wealth of information through all the social media that we have, and we're all pretty available, or as available as we can be.
With the generally mild winter we're having again, does that indicate higher odds of diseases like striped rust will be there this growing season? Are the odds increased, or does it still depend on what happens down south and
Right.
the winds coming up?
For the strike rust, it's going to depend on what's happening down south. So if this cold snap sort of does things in, then maybe we'll be okay, but we're just going to have to see how that plays out. Yeah.
The ones that aren't snowbirds that hang around here, like Septoria and powdery mildew, they're always going to be with us, and I'm always surprised, or at least they've struck over the decades or years, that boy, I can have a lot last fall, and some of your fields did, for Pete's sakes. You might come into this growing season, as it starts to regrow and develop, you might find none at all. And so not a strong relationship. But, so I think it's going forward. Once we get into green up and tillering, scouting at that time, because the environment just has so much to say. We got so much inoculum of these resident diseases that it doesn't matter too much.
Right. It's just so environmentally driven, right? So it just depends how things move forward. And please help yourself to more books on the way out too. There's plenty there if you need more.
Well, not too many. They're pretty expensive. Jody, stand by that file there.
What about location? I mean, say you got 1 year, how many years from wheat to each other? Is that a factor in this disease cycle?
So the question was about rotation. Certainly for head scab, you don't want to be planting that into corn, right, or any other small grains.
I meant a 2-year skip or 1-year skip.
I don't know if there's any good data on that, 2 versus 1 year skip. There was a paper just recently published looking at continuous corn, continuous soybean, and showing a drop-off in yields in continuous soybean and some in corn too. And Ontario just published some work a little while ago showing the benefits of small grains in that corn-soy rotation. So I don't know if a shorter rotation can just a week.
Yeah, casual observation on take-all. Rarely do we see take-all, and that one is consistent. This past year, I was in 6 fields that was wheat on wheat, and every one of them had take-all, and so you're aware of that. The other ones do hang out in debris, but for those guys on a wheat, soybean, wheat rotation, which there's quite a bit out there, it's not apparent to me that the other ones are impacted, even though they do reside on the residue.
Let's have a hand for these two.